Hi, class. It's Dr. Lindner. Okay, we're still on connective tissue. And just to review, we have a few main categories of connective tissue, right? We have connective tissue proper, and that's where we have loose and dense connective tissue. And under loose, we have areolar, adipose, and reticular. Under dense, we have regular, irregular, and elastic. Under supporting connective tissue, we have cartilage and bone. And on the cartilage, there's hyaline, elastic, and fibrocartilage. I want to focus on bone right now, and you're going to hear terms like compact and spongy bone. We're going to focus a little bit more on compact bone, okay? And then in another video, we'll focus on fluid connective tissue and discuss blood. So when we talk about bone, here is a long bone, right? We have different shape bones. We have long bones, short bones, irregular bones, flat bones. So here is a long bone. And long bones have different parts. They have a proximal epiphysis and they have a distal epiphysis. They have metaphysis, and then they have a shaft called a diaphysis. So this is the proximal bone. This is the distal. This looks like it's probably the femur. That's the head of the femur. So at the proximal and distal epiphysis, at the proximal and distal epiphysis, we have spongy bone. And in the shaft, which is called the, see if I can get this, the diaphysis. The shaft is the diaphysis. We have compact bone. So what we're doing is we're taking this part right here and we're looking at it here. So this is this, which is compact. We have spongy bone here, here, and in the middle, which is called the medullary cavity, is also spongy. So that's why right here we see spongy bone, all this trabecula. That would be here, this medullary cavity. But on both sides of the medullary cavity, here and here, that's where we have this compact bone. It looks very, very different than spongy bone. And one of the key words that you're going to hear when we talk about compact bone is the osteon. The osteon is that functional and structural unit of compact bone. Spongy bone doesn't have osteons, only compact. And the best way I could describe an osteon is if you cut a tree down and when you're looking down like a bird's eye view on the cut tree stump, you're looking at these concentric rings. Okay, so an osteon has many, many concentric rings with the very center of it called a central canal or Haversian canal, which has arteries, veins, nerves, lymphatics, that type of thing running through the center. You can see them here, artery, vein, and nerve, artery, vein, and nerve, artery, vein, and nerve. That's running through the Haversian or the central canal. And that's why when you break a bone, they bleed, and you can get a hematoma. Hematoma. It's like a tumor of blood that forms. Okay, so we have compact bone, we have spongy bone, and the compact bone has some unique terms that we need to become familiar with. These concentric rings that go around are called lamellae or concentric lamellae. The outer part of the bone is called a periosteum. The inner part of the bone is called an endosteum. So the periosteum, this is the layer where muscles attach to bone by way of tendons, and where bone attaches to bone by way of ligaments. That would be the periosteum. So spongy bone is found in the epiphysis, both the proximal and distal epiphysis. Spongy bone, or it kind of looks like a sponge that has these spaces in trabecula. So this looks very, very spongy. There are no osteons in spongy bone. The compact bone is found in the diaphysis. And again, remember, the diaphysis is here. It's the shaft of the bone, and it's both portions, the outer portion here, this inner portion here. When I say inner portion, I don't mean the inside where the medullary cavity is. It's the outer portion here and the outer portion here that is compact. The compact bone acts as a mineral reservoir. It's solid, it's dense, it's compact. It's the basic unit of bone that is called the osteon. And bone protects us. It provides movement for us because muscles attach them by way of tendons. They store minerals, so it's a mineral reservoir. It's a bank that stores calcium and potassium and magnesium. And bone is also the site of blood cell formation that's going to happen in the bone marrow, which is in that medullary cavity. Look at what makes up bone. 2/3 of bone is calcium salts. That would be like the cement, calcium phosphates. And look at what 1/3 of the matrix is collagen fibers. So 1/3 of the matrix is collagen. Remember collagen ACE or MMPs. The MMPs are matrix metalloproteinases. Those are collagenases or proteinases. So when you're chronically inflamed and you have MMPs in circulation, collagenases or MMPs go after collagen so it can break down 1/3 of bone. And when you break down bone, that's osteopenia or osteoporosis. So keep that in mind. Here is a cross-section of compact bone. You can see that we have lamellae. Those are those concentric rings. And we have these hollowed out spaces called lacunae. Now, lacunae are where osteocytes are located. Now, we have a cell that's called an osteoblast, not to be confused with osteoclast. So we have osteoblasts and osteoclasts. Osteoblasts are going to produce matrix. They're going to produce the cement, the extracellular matrix. It's an immature cell that makes matrix. So when you have an osteoblast that makes matrix, if let's say this is the osteoblast and it's producing matrix all around it, eventually that cement is going to harden and it's going to get trapped, whereas everything around it is going to solidify, and the osteoblast gets stuck in its own matrix. It gets trapped and now it can't get out. This osteoblast evolves and becomes an osteocyte, which is a mature cell. So what you see here on the top left here, an osteocyte gets stuck in its cavity. That's called a lacunae. And all around it is that calcified matrix that was produced by the osteoblast, but now it's stuck. It can't move, can't get out of its way. So the immature osteoblast evolves and becomes an osteocyte. The osteocyte has these canals, these extensions coming off of it called canaliculi. They're like little canals, canaliculi. Okay. An osteoblast builds up bone, an osteoclast breaks down bone. So the B in osteoblast builds up bone, the osteoclast, the C for see you later, it breaks down the bone. And this is just proper metabolism where you build up and break down, you build up and break down, and hopefully you build up and break down in harmony when these two are working in sync, where you build up and break down in the same ratio. We call that healthy bone remodeling. But if you start breaking down more than you're building up, that's not balanced bone remodeling. bone breaking down faster than it can build up is osteoporosis. And perhaps having lots of MMPs or matrix metalloproteinases in a chronically inflamed state, those MMPs, the matrix metalloproteinases, can break down 1/3 of bone, which is collagen. And you get osteopenia or osteoporosis. In that center right there, that's the central canal or the version canal. That's where the blood vessels, the arteries, the veins, and the nerves are. And again, here's the lacunae, which is here. That's where the osteocyte sits. And you have those canaliculi traveling through there. Okay, so the osteon is made up of those concentric rings called lamellae. All that is mineralized matrix. The matrix is calcium and phosphates. That's what's the cement that's going to give it the hardness. Whereas the collagen fibers, that's like the reinforcing steel beams, that's going to provide the strength. Okay. The canaliculi, those are the tiny canals that connect cell to cell and allows them to communicate with one another. Now, when good bone is healthy, you could see this is a vertebrae, and you notice the collagen fibers, you have the matrix, it's nice, it's solid. But look at this one, it looks very compressed. That's osteoporosis, that's a codfish vertebrae. Now, sometimes what happens, let's take a look at this person here. You see how you have this arc here that's called a hyperkyphosis. Let's see how that takes place. So if we have a healthy vertebrae here, and then a healthy vertebrae here, and then a healthy vertebrae here, these are the spinous processes, right? These are nice blocks. This is a lateral view, just like we're looking at it from here. But let's say here's a good square vertebrae, and now, and this is anterior, this is posterior, here's another anterior, this is posterior. The softest part of the vertebrae is the anterior. So this part here can break down, the anterior part. So that looks like that, right? The posterior is still high, but the anterior is soft. So now the vertebra on top of that has to contour to that. And the one beneath that has to contour to that, right? You start to see that you get this hump, which is this hump right here. You get that hyperkyphosis. Now, when you see this, we see a few things, right? We see, all right, bone softening, which is osteopenia or osteoporosis. We can say, wow, you know, if you have this type of architecture, what's happening to the lungs? The lungs are being compressed. You have decreased oxygen. You have decreased oxygen. You have decreased energy, decreased ATP. Look at the way her structure is. What's happening to the pelvis is all distorted, which compresses the intestines. So you have decreased bowel movements. You have decreased ability to digest your foods properly. You have the ear so far in front of the shoulder. This puts a lot of stress on the nerves that go to the heart and go to the lungs. So there's a lot of different things that take place here. We don't see lots of good muscle tone here. So probably decreased protein, decreased ability to absorb collagen for healthy bone. You need protein for muscle, for tendon, for ligament, for bone, for blood. Or she's consuming a good amount of protein, but maybe there's decreased digestive enzymes, which decrease the amount of protein absorption. There's just so much that you can get from structure, looking at this poor structure and determining the ill health of this type of individual. So this type of individual needs a lot of different support and a lot of different help. It's multifaceted, and there's no magic pill that could fix this. This is something that's years and years of neglect and degeneration, and we have to be able to help these people much, much earlier on in their life.